I'm Anil Kumar, and in this video we will understand how to sketch graph of first derivative from the given graph of the function. So here we are given graph of the function. We need to sketch the graph of first derivative. So we'll analyze this from left to right, one by one, and then try to understand how do we get the graph of first derivative from the graph of the function. If you see, as x approaches large negative value, let us say when x is a negative infinity, this graph is kind of flat, right? So the derivative of this function, we can say f dash x is almost equals to, or we can say approaching 0, right? So here we'll kind of have similar approaching 0. But as you go towards the right, the graph rises and is always increasing, right? So what we see is we can draw tangents, and we see that the tangent is positive, positive, and more positive, correct? And it is actually kind of maximum positive at this point, you can see. So it is concave up to this point. The shape of the graph is concave up to this point. And after this point, it is still positive, but it becomes decreasing in nature. So from here to there, what we see is that f dash x is increasing, right? So in this interval, f dash x is increasing, so it is increasing, right? And it is also positive, but at this point what we find is that it's kind of maximum, and after that f dash x is positive, but it is kind of decreasing, you see, decreasing to 0, right? So at this point the derivative is 0, since the tangent is horizontal, right? So if you analyze, then you'll find that at this point we kind of have a maximum for the derivative, correct? So what we can do is we can kind of sketch this function as let us say we are not sure about the values, but we know one thing, that it is maximum at this turning point, right? So let us say, okay, so let me redo this. Okay, so what I will do is we have to have a maximum here, so we'll say this kind of turns like here from here. So let this be my graph. Okay, not this one, okay, because I want to have a maximum here, right? So the graph is increasing, right, and it goes to a maximum at this point. It is still positive, but it becomes 0 there. Perfect. On the right side, what we see is that the graph becomes negative, because if I draw a tangent line, in that case all the tangents on this side are negative, correct? And again on this side it is negative, but it is approaching 0. So negative approaching 0 will mean that it is approaching from this side. Do you see that? Yes. And another thing which you notice here is that the graph is concave down up to this place and concave up from here. So we expect a minimum here at this point, right? So minimum at this point. So it is negative with minimum at this point. So from the symmetry, what we can do is we can kind of make a graph which is symmetrical to this, minimum at this point, and then increasing, right? So as you can see, the slope of the tangent line, it is very steep here. The point at which the concavity changes, it is always maximum or minimum, and then still it is negative, right? Still negative, but less negative. So that is what is shown here. So what you learn here is that at such points, turning points, so at turning points, f prime x, or the derivative is 0, right? So that is one thing. And then whenever concavity changes, we expect maximum or a minimum. It really depends how is the concavity changing, right? If the concavity is changing on the positive side, we get a maximum, correct? Because like going up and then down, so in that case it is maximum. But if the concavity is changing when the graph is coming downwards, then it is minimum. So it's more negative and less negative. That is what it means, right? So from more negative to less negative, let me write here. that means more negative. That means less negative, right? We get minimum as we saw. So the minimum is right there. And if the graph of the function is kind of flat, is horizontal, so the horizontal function results into derivative which is equal to 0. Since it is approaching kind of horizontal at positive and negative infinity, the graph of the function approaches 0. So this graph, which I've shown here in the red line, indicates the graph of the derivative, right? So you could analyze as we did so. So find the intervals of increasing and decreasing, and then you can get a very good, probably accurate graph of the function of the derivative. I hope that helps. Thank you and all the best.